My dear students, welcome to this series on mathematics. Today we are going to look at parametric differentiation that you're going to study at grade 12. Now, what is parametric differentiation? Suppose that I have the curve y is equal to x squared. We all know this famous curve, this famous parabola y is equal to x squared. If I tell you, you know, x coordinate is 1, you will tell me y is 1. When x is 2, y is equal to 4. When x equal to minus 2, y is equal to 4. Imagine for a few seconds that you're running a business. You're running a business. That's you, right? And you go to a foreign country, right? Any foreign country. That's your counterpart. And unfortunately, you are unable to speak a common language. So that's you. I represent that by y. What do you think you would need? You have to do the business, you have to run the business, you're already there, you have to deal with your counterpart. Obviously, what you would need would be what? An interpreter. All right? An interpreter who can talk to you and talk to your counterpart. In mathematics, that interpreter is called a parameter. A parameter that we represent by letter t, theta, and so on. So now what will happen is that you are going to talk to the interpreter. So I will have an equation connecting y to t. And then I will have another equation connecting x to the parameter. So instead of having one equation, here we had only one equation. Here we had only one equation. Here we are going to have two equations. So one will be y in terms of t. That is, I'm going to have y as a equation in terms of t, and x as an equation in terms of t. This is called the parametric equation of a curve. Now, very often, when confronted with the parametric equation, students have a tendency to say, well, we had one nice equation of a curve, why split it into two? For obvious reason. Here, a point was defined by two coordinates, whereas here, a point is defined by one value of the parameter. Now, why it is important in real life? Imagine you have created a cartoon or a robot, right? If the movement of the robot head is denoted by x, the left hand by y, the right hand by z, right? The legs by uv. Imagine the state of the robot if we had to move each part one by one. The head might have remained behind and the leg would have been forward. But if we write all of them in terms of a parameter, We just have to change the value of the parameter, and all of them will change simultaneously. So that's the advantage of a parameter. So don't be here, when you look at the two equations, don't say, well, it's a waste of time. One equation, why split it into two? It has its advantage. The advantage is that you have only one parameter controlling everything. For this curve now, y is equal to x squared, I will ask you to parameterize it. What does it mean? Parameterize this equation. Introduce a parameter. So first step that we can do is to say let x equal to t. Step 2, y is equal to x squared is equal to t squared. So the curve y is equal to x squared has parametric equations x equal to t and y is equal to t squared. Now, let's look at this point. X equal to 1, y is equal to 1. Instead of saying x equal to 1, y is equal to 1, I will simply say t is equal to 1. Here, x equal to 2, y is equal to 4, I will simply say t is equal to 2. When I tell you t is equal to 2, and you know the equation, you can easily calculate the coordinates. Let's say I tell you at a point t is equal to minus 3. What are the coordinates? If t is equal to minus 3, then the coordinates will be what? Minus 3, and then here minus 3 to the squared, 9. So rather than giving the coordinates, I am now giving you only one value of the parameter. So it is sufficient to give one value of the parameter in order to know what x will be, what y will be. That's the biggest advantage. And as I told you, in the case of the robot, everything is parameterized so that the hands and all the parts of the body can move simultaneously. Let's look at the fundamental equation in this chapter. The parametric equation of the curve are y is equal to ft and x equal to gt. As the previous chapters we have done, let's say on implicit differentiation, you have to find the gradient of the curve, and as you know, gradient of curve is dy by dx. So let's differentiate this equation. So I will differentiate y. This is the equation connecting y to t, so I will obtain dy by dt. Differentiate the second equation, we obtain dx by dt, which is, remember, it is an equation connecting y to t, so I differentiate y with respect to t. Here it's an equation connecting x to t, so I differentiate to obtain dx by dt. What will be dy by dx? Because gradient of curve is dy by dx, so it is dy by dt times dt over dx, or dy by dt divided by dx by dt. That's the main equation in this chapter. We'll now take an example. a curve has equation x equal to ln tan t and y is equal to sine square t, where t is restricted to take values between 0 and pi by 2. Find dy by dx first, and second, equation of tangent when x equal to 0. So a curve has equation x equal to ln of tan t and y is equal to sine square t. Find dy by dx and equation of tangent at x equal to 0. So x equal to ln tan t, y is equal to sine square t. What is dx by dt? When I differentiate ln tan t, what will I get? Tan t in denominator, differentiate tan t. So we'll obtain, differentiate tan t, we obtain sec squared t over tan t. You can simplify that further if you want. Sec squared is 1 over cos squared t divided by tan t, which is sine t over cos t, 1 over cos squared t, cos t over sine t. This cancels, leaving 1 over cos t sine t. Similarly, this is dx by dt. Y is equal to sine square t, which is sine t to the squared. What is dy by dt? 2 sine t. Differentiate sine, obtain cos t. So 2 sine t cos t. What will be dy by dx? So I differentiated the first equation, x equal to ln tan t, to obtain 1 over cos t sine t. Then I started with the second one. I differentiated to obtain 2 sine t cos t. What is dy by dx? Dy by dx is dy by dt over dx by dt. What is dy by dt? 2 sine t cos t. What is dx by dt? 1 over sine t cos t. So this gives us 2 sine square t cos square t. This is dy by dx. So this is what we were asked to show. Dy by dx is 2 sine square t cos square t. Now, the second part, we were told to find equation of tangent when x equal to 0. Now, x equal to ln tan t is equal to 0. So, if we move the tan, exponential 0, this gives us 1. T is equal to tan inverse 1, which gives us pi by 4. Remember, the angle is in radian, always in radian when you integrate and differentiate. So when I integrate or differentiate, the angle must be in radian always. So t is equal to pi by 4. So I was told, write equation of tangent when x equal to 0. And in the question itself, we were told x equal to ln tan t. So I equated x to 0, ln tan t to 0. Right? Getting rid of the ln gives us exponential 0 on the right-hand side, which is equal to 1. Tan inverse of 1 is pi by 4. So equation of tangent. What is equation of tangent? Y is equal to mx plus c. M is dy by dx 2 sine square t cos square t. Sine pi by 4 to the squared cos pi by 4 to the squared. So this gives me half, this gives me half, so the gradient is half. Sine pi by 4 is 1 over root 2. So 1 over root 2 to the squared is half. Cos pi by 4 is 1 over root 2. Square it, I get half. 2 times half, 1. 1 times half, half. We know that x equal to 0, and we have got half. We need to find y. Y is sine square t. So it is sine t to the squared, sine pi by 4 to the squared, which is half. So gradient of the tangent is half. The point is x equal to 0, y is equal to half. Y is equal to mx plus c. Replace y by half, x by 0 plus c. C equal to half. So equation of tangent is half x plus half. So this can also be written as 2y minus x minus 1 equal to 0. So here we were given parametric equations. We differentiated dx by dt. And then we differentiated the equation connecting y to t to obtain dy by dt. And then finally, we obtained dy by dx. So we found the value of t to be pi by 4, and then replaced it in dy by dx to obtain gradient. And then for t equal to pi by 4, we found x, we found y. So we have a gradient, we have the coordinate, we wrote the equation of tangent. All right, we'll take another example. A curve has parametric equations, x equal to a cos cube t, and y is equal to a sine cube t, where a is a positive constant and t lies between 0 and pi by 2. First, find dy by dx. Second, show that equation of tangent at any point with parameter t is x sine t plus y cos t, a sine t cos t. If this tangent meets x-axis at x and y-axis at y, then prove that xy equal to a. Now, solution, x equal to a cos t power 3. It means dx by dt will be equal to what? 3a cos square t, differentiate cos minus sine t. So this becomes minus 3a cos square t sine t. Y is equal to a sine t cubed. Remember, these two equations were given already in the question. dy by dt equal to 3a sine square t, differentiate sine, we obtain cos t, so this gives us 3a sine square t cos t. So we have obtained dx by dt, we have obtained dy by dt. And as you know, to obtain dy by dx, what will we do? Dy by dt divided by dx by dt. What is dy by dt? 3a sine square t cos t. What is dx by dt? Minus 3a cos square t sine t. So, obviously here you find that these will eliminate, leaving cos t here. This would eliminate, leaving sine t here. So I'll be left with sine t over cos t with a minus, which is minus tan t. So that's dy by dx. Now, what am I asked to do? I'm asked to write equation of tangent at the point with parameter t. So for tangent, m is equal to dy by dx, and we just found that it is equal to minus tan t. At what point? At the point with parameter t. So this is a cos cube t, a sine cube t. So what is the equation of tangent? Y is equal to mx plus c. So to find c, what will I do now? Replace y by a sine cube t, m by minus tan t, x by a cos cube t plus c. So c will be equal to a sine cube t, which was here. This goes on the other side, becomes plus tan t, a cos cube t. So here we have a sine cube t. Tan t is sine t over cos t. Cos cube t. Obviously here we have cos, which cancels, leaving here cos square t. So I have a sine cube t plus a here sine t. I have a here, sine t here, cos square t. We find that there is sine t common. We can factorize a sine t here, leaving us what? Sine squared t here, and here cos squared t. And by trigonometric identity, this will be equal to 1. So this gives us a sine t. This implies c is equal to a sine t. So we are going to write the equation of the tangent, and we have been asked to prove that this is what the equation of tangent will be. So we know what is m. M is minus tan t, minus sine t over cos t. C we have already found is a sine t. So y is equal to mx plus c gives me y is equal to minus sine t over cos t. X plus c. I'm going to multiply all terms by this cos t. So this will give me y times cos t minus sine t. X plus a sine t cos t. And this is what we had been asked to prove. That's the general form of the tangent. We had been asked to prove the general form of this tangent, which is y cos t plus x sine t. So you realize that we had a number of trigonometric identities here to be used. So even in this chapter, you will use your knowledge of trigonometry. Let's do the last part. What does the last part is telling us to do? The last part is telling us if this tangent that we have just proved cuts x-axis at x and y-axis at y, prove that the distance between these 2 points will always be equal to a. So the third part, we proved in fact that the equation of the tangent is x sine t, y cos t equal to a sine t cos t. Now, we are asked to show that if this tangent is going to cut x-axis at x and y-axis at y, then distance xy will always be equal to a. Now, when a line will cut x-axis, what happens? When it cuts x-axis. On x-axis, all y coordinates are 0. So what will happen here? If I replace y by 0, we'll have x sine t. Here it will become 0 because y is 0 equal to a sine t cos t. So I will be left with x equal to a cos t. When it cuts y-axis, x equal to 0. So I replace x equal to 0. It will be 0 here. Y cos t equal to a sine t cos t. So y will be a sine t. What is the distance? So I have the point x, which is a cos t 0, the point y, which is 0 a sine t. What is the distance xy? A cos t minus 0 squared 0 minus a sine t to the squared, which gives us a squared cos squared t, a squared sine squared t. So a squared cos squared plus sine squared t. Cos squared plus sine squared t, c'est trigonometric identity, equal to 1. And therefore, this is what we had to prove. So, my dear students, in this chapter, we have looked at implicit parametric differentiation. Previously, we looked at implicit differentiation. Now, both chapters, implicit differentiation and parametric differentiation, right? What is important in these two chapters is to find dy by dx. You have to be careful while finding dy by dx. And after that, you will be asked to find equation of tangent, equation of normal, right? Which you're going to do in a routine way. My dear students, you have seen that in this chapter we considered parametric differentiation. Why it is important that a curve be represented by two equations. And you have seen how we found dy by dx, equation of tangent, normal, and how to manipulate all those functions that involve trigonometry, logarithm. So, I hope you have enjoyed this session on parametric differentiation with us. Until next time, it's goodbye from us.